Hey friends, hi. I am Sachin Nasari and I am an IT engineer and I have started this YouTube channel particularly to support students who are appearing for 12th standard and also for 10th standard. I'll be covering subjects like physics and mathematics in order to help them understand the concepts, understand the formulas, how to derive them, how to solve sums which are complicated. Welcome to this channel. I wish you all guys subscribe to my channel. Hey friends, hi. So, Today I'm going to start with physics chapter rotational motion. So, we'll be covering each and every module of rotational motion in different videos, and it will be helpful for you because we'll be covering each module in depth in each video. We'll be covering all the formulas and everything in the end of this chapter, when you will collate all the formulas that you have been taught in the entire course, when you collate all those, it will be helpful for you to use it in your competitive exams. Let's start with rotational motion. So before starting, let me give you some understanding of what is rotational motion is all about. So let's first understand the characteristics of circular motion. Okay, so there are basically two characteristics of circular motion. Okay, it is the first characteristic is that it is an accelerated motion. As the direction of the velocity is continuously changing, as you can see, if I move this pen, if I rotate this pen, as you can see, each and every particle's directions are continuously changing. So since the velocity is continuously changing, it is an accelerated motion. We call acceleration as the change in velocity. So since the velocity is changing, we call it as accelerated motion. So that is the first characteristics of rotational motion. The other characteristics is that it is periodic in nature. So the particles that are obeying circular motion follow a repetitive path. They follow a repetitive path. They follow a particular path after a particular frequency. After a time period, they follow the same path. So these are the two characteristics of rotational motion. First, that it is an accelerated motion. Second, it is periodic in nature. So now as we have understood the characteristics of circular motion, let's understand the kinematics of circular motion. So we'll understand each one of these parameters in depth, so that because these parameters are vastly used in next modules of these chapters, so it is very important that you understand this particular parameters very thoroughly. So the first thing is angular displacement. Now angular displacement is the angle through which a particle moves with respect to the center. Okay? So if let's say this is a particle moves from here to here with respect to the center, this becomes the angular displacement. So we call that as theta. Okay? So this is the measure of that angle from point A to point B with respect to center. Okay? So that is angular displacement. Now what is angular velocity? So basic simple calculus. So it would be the change in angular displacement with respect to time. So angular velocity would be equal to change in angular displacement with respect to time. So this becomes your angular velocity. Okay. Now what would be the direction of this angular velocity? Okay. What would be the direction of this angular velocity? So to find out the direction of angular velocity, we have to use a basic right hand thumb rule. Okay. So when you cross your right hand, when you cross your right palm like this, so if they are rolled in this direction, and if they're rolled in this direction, then the thumb represents the direction of the velocity, angular velocity. So it's like opening a box. So it's a circular motion, but the velocity of that box is upward. So that's why, if the motion is like this, the angular velocity would be upward. In the reverse way, if the motion is like this, then the angular velocity would be downward, like tightening a box or tightening a top. Okay. So that's how the direction of angular velocity would be decided. So if you see there, so if it is moving like this, the angular velocity would be up. If it is moving like this, the angular velocity would be down. So that is angular velocity. And we have understood how to identify the direction with the help of right hand thumb rule. So now what is angular acceleration? Again calculus, that is the change in angular velocity with respect to time. So that is represented by alpha. Okay? So alpha is basically equal to change in angular velocity with respect to time. Okay? So this is angular acceleration. The rate at which the angular velocity is changing is known as angular acceleration. So let's now understand what is tangential velocity. So if a particular body, if a particular particle, let's say if I'm tying this a particular stone from this rope of, let's say, radius r, and it is having a circular motion, okay? So it is having a particular angular velocity, let's say omega, okay? So at some point of time, let's say if this rope breaks, so what would happen? This particular thing will go in a tangential direction. This particular particle or this particular object will go in tangential direction. So that thing will go in tangential direction in a velocity called tangential velocity, linear velocity. Okay? Tangential velocity. So how would we calculate that? So tangential velocity is nothing but the cross product of angular velocity and your position vector, or you can call it here as radius if it is origin. Okay, so radius. So that would be omega into r into sine of 90. So, but as we know that the angle between the velocity and the radius is 90 degree. So sine of 90 is 1. That's why velocity is equal to omega times r when we are calculating the magnitude. Okay, when we are calculating the magnitude. So the linear velocity would be equal to r times the angular velocity. So here we come up with the first formula, that linear velocity is equal to the angular velocity. So we know the basic formula of how we calculate the speed. Speed is nothing but distance upon time. Okay, so what would be the distance of this circle? What would be the distance of this circle? If I want to calculate the magnitude of this omega, what would be the angular speed or the magnitude of that angular velocity? It would be the distance upon time. Now distance in terms of angular is the angle. So this angle is nothing but 2 pi by t. So here t is nothing but the time period. Now what is time period? It is the time taken by that particular object to complete one cycle. Okay? So that is time period. So, and the inverse of that is nothing but the frequency of that particular angular motion. So this can also be written as 2 pi n. Okay. So in this we have understood two formulas. Basically, one being V is equal to omega r, and the other one being omega is equal to 2 pi n. Okay, where n represents, now this is your formula number 1, formula number 2. Okay, slowly we will be covering more formulas in the next module. Thank you.